6.5 is about conditions for rhombuses, rectangles, and squares. 6.16, in Theorem 6.16, it says that if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. So we're basically just going and flipping the theorems we talked about last section and using this one. Okay? In Theorem 6.17, it says if one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. Why? Because the diagonals are angle bisectors. Talked about that again last chapter, or last section. Theorem 6.18, if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So again, we're just going in reverse. So we're identifying parallelograms in A. If we look at this diagonal here, it bisects both angles. So I would say this parallelogram is a rhombus because diagonal bisects the angles. Okay? If we look at B, we know that our diagonals are congruent because of the 1 markings on each one of them. So since each half is congruent, we could say that yes, the diagonals are congruent. Yes, diagonals are congruent. Are congruent, making it a rectangle. And since the diagonals are perpendicular, it's a rhombus. So since it's both a rectangle and a rhombus, therefore it's a square. Problem 2 talks about using the properties of special parallelograms. They tell you that parallelogram ABCD is a rhombus. So if they're saying it's a rhombus, you know the diagonals bisect the angles. So I can say that 6x minus 2 equals 4x plus 8. Okay, let's go ahead and solve. Subtract the 4x over. I get 2x minus 2 equals 8. Add 2, you get 2x equals 10. Divide by 2, x equals 5.